All right, let's get right into it. Today, we're going to talk about a secret code, a hidden pattern that seems to connect everything from the biggest things in the universe to, well, our own thoughts. It's the language nature uses to build reality, and we're just now starting to teach our machines how to speak it. So, I want you to start by picturing a galaxy. Those enormous, swirling arms of stars and dust. The scale is just mind boggling. But that pattern, doesn't it feel a little familiar? Okay, now zoom way, way down to something you could hold in your hand, like a fern. Look closely at one of its fronds. See how it's basically a perfect little copy of the bigger branch? And that branch is a miniature version of the whole plant. Or what about music? Think about a song you really love. There's usually a main theme, right? A little melody that then repeats and twists and builds on itself, creating this incredible, complex piece from just a few simple notes. And then, let's get really weird. What about a thought? When you remember something, it's not just one isolated thing. That memory is connected to other ideas, which branch off into more feelings and more memories. It's like a web, constantly looping back on itself. So you've got galaxies, ferns, music, the very structure of our minds. I mean, these things couldn't be more different. So what in the world is the connection? Is there some single elegant principle that ties them all together? Well, there is, and the answer is fractals. You can think of them as nature's secret code. It's a surprisingly simple set of rules that nature uses to create almost infinite complexity. It's like the underlying operating system for patterns, for growth, for pretty much everything. So what exactly is a fractal? It really just comes down to two big ideas: self-similarity and recursion. Self-similarity just means that if you zoom in on any part of the pattern, you see a smaller version of the whole thing. And recursion, that's the engine. It's just a simple rule that you repeat over and over and over again. Let's make one. It's actually incredibly easy. Take the Sierpinski triangle. It looks super complex, right? But it's built from one dead simple rule. You start with a triangle, you find the halfway point on each side, connect them to make a new triangle in the middle, and then you just get rid of it. Poof. Now, you just do that exact same thing to the three smaller triangles that are left, and you keep doing it forever. That's it. You've just created infinite complexity. And here's the cool part. Once you know this pattern, you start seeing it absolutely everywhere. It's in the jagged, repeating shape of a coastline. It's how your blood vessels and neurons branch out. It's in the chaotic flicker of a lightning bolt, and yep, even in how galaxies are scattered across the universe. It's all the same code. Okay, so if this is nature's fundamental playbook for creating complex things, what happens when we teach our artificial intelligence to think using this playbook? What kind of a mind are we building then? This really gets to the core of it. Most AI today thinks in a very flat way. It's like trying to understand a city using a simple, flat street map. It's great for getting from A to B, but language and ideas aren't a flat grid, are they? They're more like a tree, with concepts nested inside other concepts. A fractal approach gives AI a totally different kind of map, a curved, hyperbolic map that lets it understand all those deep, layered relationships, kind of like how we do. And this isn't just some sci-fi idea. People are building this right now. It's a whole new toolkit for AI. Each of these models gives an AI a unique way to process the world. A Sierpinski decision tree, for instance, lets it solve a huge problem by breaking it down into smaller, identical versions of itself. Or something like a toroidal network helps it keep its train of thought stable and coherent, which is a huge deal for AI. So the ultimate goal here is to build an AI that doesn't just process a sentence word by word. We want a system that gets the subtext, the deep, hidden relationships that actually give language its meaning. We want an AI that doesn't just know what you said, but understands all the layers of meaning behind what you said. So how does this actually work in practice? Well, you use techniques like hyperbolic word embeddings. This finally lets an AI understand that, say, a poodle is a type of dog, which is a type of mammal. It can see the whole family tree of ideas, which is something flat systems are terrible at. Then you have things like the toroidal models, which act like a gyroscope for the AI's logic, making sure it stays balanced and coherent as it learns. This is the difference between an AI that can translate a sentence and one that could actually understand a poem. But here's the catch. This whole revolution isn't just about writing smarter software. The actual physical machines we're running it on, they're hitting a wall. To really let fractal intelligence run free, we need to completely rethink the computer chip itself. You see, our current computer hardware has some pretty big problems. You've got these massive data traffic jams between the different parts, like the CPU and the memory. They're not great at doing a lot of things at once, and because of that, they just burn through incredible amounts of power and get super hot. Now, this is where things get really wild. What if you design the physical layout of the chip to be a fractal, like the Sierpinski carpet? By doing that, you create these incredibly efficient pathways for data to move around. It's like designing a city with a perfect road system that works at every single scale, from massive highways all the way down to tiny side streets. This design could just demolish those data traffic jams and make the whole system way more powerful. And that brings us to the biggest, most mind-bending idea of all. Let's zoom way out. What if this isn't just about building better, faster tech? What if embracing fractals gives us a fundamentally new and more accurate way to understand the logic of reality itself? The philosopher Wittgenstein had this idea that logic isn't something we just invent, it's the actual structure of the world. But here's a thought. What if our old-school logic, based on simple true or false, is just too clunky to describe a universe that is so deeply complex and recursive? This leads us to something totally new called hyperbolic logic. Forget true or false for a second. Imagine every idea is a point on a curved map. The truth of a connection between two ideas isn't a yes or no question anymore. It's the distance between them on that map. The closer two ideas are, the stronger their logical link. What we're looking at here is a huge step in the evolution of reason itself. We're potentially moving away from a rigid, black and white logic to a new kind of geometric logic that's continuous, that's self-similar, and that works at different zoom levels. It's a system that feels, well, it feels a lot more like how the world actually works, more organic. Which leaves us with one last really big question. We see these fractal patterns everywhere, from our own DNA to the cosmic web of galaxies. Now, we're building machines that think in fractals and even developing a new logic based on them. So are we just inventing another clever tool? Or are we maybe, just maybe, finally learning to speak the native language of the universe itself?